Okay, and here is our first car where I am planning to do this compression test, and this is Toyota Corolla, year model 1995, and there is this 1.6 or 1.8 liter 4-cylinder gasoline engine. Okay, and there is mileage about, I think that 200,000 miles or 360,000 kilometers. And smoke test results are okay, but only issue is that there is idle speed issues when this is hot, this engine, and that means that maybe these piston rings are and pistons are too worn out. But this car is quite okay to drive, but not excellent. Okay, and then there is this second car where I am planning to do this compression test, and this is Toyota Camry car where is 2.4 liter gasoline engine, and mileage is about 150,000 miles or 250,000 kilometers, and engine is in excellent condition, in excellent engine, no any oil consumption or consume, and no any oil leaks, and power are excellent, and smoke test results are excellent, and that's I believe that in this car there are really good compression test results. Okay, and then we continue. Okay, and then there is third test car, and this is this Nissan car where is this Nissan 1.8 liter engine, and there is mileage quite low amount, about 100,000 miles or 150,000 kilometers, and engine should be in excellent condition, no any issues, no any oil leaks, no any oil consumption, and engine don't eat oil, and smoke test and emission test results are excellent, and that's I believe that in that car there are excellent compression test results. Okay, then we continue. Okay, and here we have this Honda CR-V car where is mileage about 250,000 miles or 360,000 kilometers, and there is now issues in this engine that this engine eats engine oil and motor oil about 1/4 or 1 liter per 1000 kilometers or 1000 miles, and then also I had issues with smoke and emission test, and that means that this engine is quite worn out. But let's look what compression test result shows and what information those results give to me. Okay, and then we continue. Okay, and then I am planning to do test that how much this my cars, this compression rates, there is my compression rate meter, that red box, and when I measure my car's pistons, this compression rates amount, that how much this my engine pistons can generate this compression. Toyota Corolla and first cylinder, and let's look results, and I go to start engine. Okay, and I start still a little bit. Okay, and there is this final result. 11.25 is the maximum. Okay, and then I have in here this Toyota Camry car. There is this 2.4 liter VVTi engine, and I have installed that compression meter in there. And next I am planning to check that how fast and in what behavior these compression rates become higher when I start this car longer and there is many of those piston cycles and rotations. Idea is that I check what is this compression rate when there is first cycle and then second cycle and third and fourth, and final one is the maximum pressure rate. And this my cylinder compression rate measurement tool. There is this unit is bar PAR, and then I go to next start this engine. Okay, and I go to start engine. Okay, and let's look result. There is now 12.30 and I start again. Okay, and now there is 12.90. Okay, and I start maybe even a little bit more. Okay, and now there is this 12.90. Okay, and this is now like maximum amount. Excellent. And this Camry's engine is in good condition. There is mileage about 150,000 miles, and in kilometers about 250,000 kilometers, and engine is excellent condition. There is very good power in this engine, and also there is no any oil consumption. Or actually this car eats this oil something like 0.1 quarter per 7,000 miles, or in kilometers it means that 0.1 liter per 10,000 kilometers. And this means that actually this engine it don't consume oil, because in some cars can consume 1 liter or 1 quarter per 1,000 kilometers or 1,000 miles, and this engine consumes 0.1 liter per 10,000 kilometers. It's like 1 deciliter per 10,000 kilometers. Okay, good. Okay, and then compression test for Nissan 1.8 liter engine, and there is this This car is Nissan Almera, and I checked that can we see those results. Okay, and then I go to start this engine. Okay, there is pressure is 10.35, and I reset this again, and let's look again. I go to start that. Okay, good. Now we have good results. Okay, and then we have this Honda CR-V 2-liter gasoline engine compression test, and there is my compression tool, and let's focus closer. We can see those results. And okay, now there is 0, 0. Good. Good. And a little bit better view. Okay. Okay, now we can see those results, and then I go to start this engine. Okay, and there are those compressions 8.2. Okay, really low amount. This is so low amount that I need to recheck these things, that is there anything okay. I check that is this gasket fine. Yes. Then I rotate the back. Good. And then I reset this meter and I install this device. Good. Now it's there. Then we take closer review. Now we can see that what are those measurement things in there. Good. And then I go to start this car. Okay, and now result is 10.0, 10.3. Okay, good. Okay, and this was good information. Okay, hello and welcome. How are you doing? And next I am planning to show you test result and idea that how I can know that is this my car's engine okay or worn out and bad. And the solution is that I need to do compression test for each of those cylinders, and there is idea that I need to look with this compression meter. I have in here one of those compression meters. This is a little bit difficult to read because there is those text in Deutsch, or what is this in German text, but I understand that this is cylinder and so on, and this Lösen is, I have checked that this is like reset. Okay, and when I use that kind of meter and then this tube what I install in this cylinder head spark plug hole, and this must be, by the way, very clean. Oh sorry, it must be clean. And then when I connect these systems together, there is connector, then I can measure when I insert that in this spark plug hole. I can measure that what is compression. And there is then idea that we need to look that how fast then when these cylinders are moving, that how this compression start to increase. And now I have made my test result in this engine, and this is like Toyota Corolla's engine, and then also Toyota Camry's VVTi engine, and one Nissan engine, and also Honda CRV 2-liter engines compression test. And soon you can see, and here are those results what I can later show you, and I can explain that first is this Toyota Corolla, what is this engine, and next one is Toyota Camry, and then is Nissan, and the final one is Honda CRV. And this is like first compression when cylinder comes out, and then second when the same cylinder comes again up, and then third time when same cylinder, and it seems that this compression increase. And then this is final result when I have started this engine like 1 minute. Okay, but then let's go to look that what kind of results I can get. Okay, and here then I have these results when I made those when I made those 4 cars compression test results, and I checked that what are those cars engines quality, and this means that there are cars names Toyota Corolla, Toyota Camry, Nissan, Honda, CR-V, and then there is this cylinder's first cycles bar, and this compression unit is bar, and it shows that one of those cars, this first stroke and this first cycles pressure is really low, and it's Honda CR-V. And then when this piston goes up and down and again compression turn, it shows that again there are 2 bad engines, this Honda and then this Toyota Corolla. And then when I start that more, it seems that still this Honda's engine is very low compression, and then when I have started that engine 1 minute, in that after that time this Honda's compression is 10 bar, and then when we compare, Nissan is 10.7 and then Camry 12.90 and then this Toyota Corolla 11.25. And what that means, this is really excellent information. I have been issues with this Honda CR-V's emission test, and also the CR-V consumes quite much this oil, engine and motor oil. It consumes something like 1/4 or 1 liter per 1000 miles or 1000 kilometers, and it eats really this engine oil. And I believe that there is now issue that piston rings and piston is burn out, and this engine is quite bad and quite end. And I have to do something with that car, maybe replace new engine or then install new piston rings in this Honda CR-V. And in this Honda CR-V's also those emission smoke test results are also very bad. It is really difficult to pass those smoke tests because this car is so smoggy. But then these other cars, this Camry is in excellent condition, no any oil consumption, and mileage is something like 150,000 miles or 250,000 kilometers, and Honda's mileage were about 200,000 miles or 350,000 kilometers. And this Nissan Almera and this Nissan, it is the most newest one, and there is only mileage something like 70,000 miles, and it is in kilometers something like 150,000 kilometers. And then this Toyota Corolla, there is quite much mileage, something like 200,000 miles and 350,000 kilometers. And it eats also a little bit this oil, but there is no any bad smoke issue in that Corolla. But in this Corolla there is issue that when these compressions are low, there is thing that this car, when engine is hot, this car stops, and this engine stops suddenly in idle speed, and it is really bad. Actually not really bad, but it is quite bad issue, because I have to start my car always when I am in some intersection or when I stop my car, because when this Toyota Corolla's idle speed became low and there is low compression rates, then this engine stops and ends running by self. Okay, and in that column there was those max compression bars when I started this start motor about 1 minute, and there is in Corolla 11.20, Camry 12.90, Nissan 10.70, and then this Honda CR-V 10.30. Okay, and what are those my recommendations? When we do this compression test, it is always to good check that how these compressions start to increase when pistons moves up and down. This is like first cycle, second, third and fourth, and this is like 1 minute running, like 20th cycle. Okay, that kind of information, and thank you for watching, and have a nice day to you. And next I am planning to maybe do some engine replace in this Honda CR-V and also this Toyota Corolla. Okay, thanks.